In this unit we're going to look at capacitors and inductors and how they function in alternating and maybe perhaps in a little bit of direct current circuits. So capacitors and inductors. Now we looked at inductors a little bit in the last lesson. We saw that inductors have an EMF induced in them that opposes a changing current. Well, capacitors are similar but entirely different. Okay, so a capacitor is essentially a charge storage device. Okay, so capacitors store charge, and the way they do that is they have two plates, two conductive plates that are separated by an insulator. So this is the circuit symbol for a conductor, two parallel lines with wires coming off of them. If I were to hook this to a DC voltage source, then what would happen is electrons would be pulled from one side and placed on the other side. So we'd have a charge of Q over here and a charge of negative Q over here. And because of that separation of charge, there would actually be an electric field from the positive to the negative. And so we actually measure capacitance in farads. And a farad is an obscene amount of capacitance, but 1 farad is 1 coulomb of charge with 1 volt of potential difference between the plates. We usually measure in micro and picofarads, so times 10 to the negative 6, times 10 to the negative 9th, times 10 to the negative 12th. We have very small capacitance, but we can build these new versions of things called electrolytic capacitors, which can have fairly large capacitance. What do we use these for? Well, these store energy in electric fields. And you guys looked at this in lab, and you know that they discharge and recharge. So in this, charge is going to flow all the way in here until the voltage between these two plates matches the voltage here, and at that point charge stops flowing. Now if we were then to route some of this charge by taking a switch, say from my power supply, cutting that open, and then going through a light bulb, then this will discharge through the light bulb. So it stores energy in electric fields, and it charges and discharges in time. Okay. Now, what that means is we can actually use this in an alternating circuit, and it's interesting in an alternating circuit because if we put it with alternating current, what we get depends entirely on how quickly this circuit is alternating. If we have these two things in parallel, okay, well, for very high frequencies, there's not very much time before this thing reverses current. So there's not enough time for the charge to build up here and create that voltage back the other direction. So at a very high frequency, this acts like just a straight conductor, and so this can go right through here and around this loop. However, if we go to a low frequency, then this capacitor is going to charge up. That's going to create a voltage opposite of this voltage, which is going to basically say, hey, instead of the current coming through this branch, go through this branch. And so what we get is what's called a high-pass filter. And what I mean by that is high frequency AC passes through, but low frequency is blocked. Okay? Now this is a very simple circuit, but you can see because it takes time for these plates to charge and discharge, very rapidly changing things can charge and discharge, but so very rapidly this is going to pull electrons from one side and push it to the other, and there's not going to be a very big voltage built up before it reverses and goes the other way. But slowly a big voltage can build up enough to oppose that, and so low frequency doesn't go through. Now an inductor also stores charge, or stores energy, but not as charge. Inductors store energy in magnetic fields. Okay? And so these work slightly differently. Again, if I were to put my power supply here and put it in parallel, and I'll have an inductor, and a symbol for an inductor is just a coil, because an inductor is coils of wire, sometimes with an iron core, sometimes not, and my resistor, If I were to build this, well, let's think about what happens for very low frequency. At low frequency, actually the electricity could go through the resistor or through the inductor. And at low frequency, there's not very much back EMF because the change in flux is small, which means the back EMF is small, which means this thing basically is just a short circuit through there. So low frequency passes. But high frequency, well, if we have high frequency, then our change in flux is going to be big, which is going to induce a big EMF in this thing. And so that's going to actually prevent current from flowing through this, and it'll all go this way. So what we have is a high frequency is blocked. And so this is a low pass filter and a high frequency blocker. Now you could actually put the two together in a circuit. Say we took a capacitor and we charged it, and then we put it in a loop with a not a resistor, but an inductor, so that should be coils. Now what would happen? Well, as charge flows first this direction, we have a big electric field here which is storing energy, and it's going to push electrons around, and so those electrons are going to come through here, and that's going to arrest that sudden change in current. It's stored as a magnetic field. We'll get an EMF back the other way, and so it'll send the current back, and we'll just get these oscillations of transferring between electric field, magnetic field, electric field, magnetic field, electric field, magnetic field. And so you can build an oscillating circuit out of an inductor and a capacitor.